Hi there, I'm Steve, and welcome to this video. It's a companion to our article, a 15-minute guide to real-time machine learning. If you didn't come from the article, please check out the description below for the link. A quick explanation of the scenario here. We're a bank who wants to predict fraudulent transactions in real time before allowing them to be processed. So we're going to be building a real-time stream processing pipeline that will output a binary value. Either the transactions will be processed or they won't, true or false. We've already obtained some data from Kaggle and then trained a model using XGBoost. We've divided the processing that needs to take place within Quix into 3 steps. Step 1, we're going to stream the data into Quix. Step 2, we're going to clean the data and prepare it for the prediction model. And in step 3, we're going to run the model. So to get started with step 1, we're first going to create a topic to receive the raw data. Once the topic has been created, we'll create a project based on a library sample. So navigate to the library, choose the Write tab, make sure you've selected Python, and then choose the Fraud Detection Ingest sample. Select the topic that we created previously, and then save the code as a new project. As you can see, here we have the raw data which we'll be ingesting, and a quick look at the code tells us we're using Panda data frames to read the CSV file 5 lines at a time. And now we'll deploy this project to the Quix serverless environment. All we need to do is give it a name and change the deployment type to service. Once the code has been built, deployed and is running, data will automatically start flowing into our topic. In stage 2, we'll clean the data so it's ready for the prediction stage. Again, we'll need a topic, so we'll create one called cleaned data. And then we'll again use the library samples to obtain our code. Note that after selecting the input and output topics, our code is pre-populated with everything that it needs to connect. We'll save this to our workspace and then take a look at the code. Each time a new row is received from the stream, we call this clean function. This ensures that we've got the correct input and output columns and that any data is mapped using dummification. And now we'll once again deploy our code as a service. Once it's been deployed, it will immediately start processing data from the stream. Next up, we need to make predictions on the cleaned data. So again, we'll need a topic. We'll call this one prediction. And we'll use another model from the library. This time, the fraud detection predict model. Choose the input topic as the cleaned data and prediction as the output topic. This is a quick look at the code. Now let's save it as a new project. Again, all the parameters, properties and credentials have been pre-populated for you. All we need to do is give it a name and change the deployment type to service and click deploy. Once the deployment is complete, the model will automatically start processing data from the cleaned data topic and output the predictions to the predict topic. After the ingest stage, all the data in this example is real time, so we'll again use the library samples to output the predicted value in real time. I'll just replace the default code with a print statement to display the predicted value. I'll then run this code within the code editor without the need for deployment. As you can see, all of the previous predictions have been retrieved from the message bus. So just because we weren't running this code, it doesn't mean we've lost any messages. We can safely stop and restart this code, and it will pick up where it left off. And as you can see, we're now producing predictions in real time as they're streamed in from the ingest stage. So to wrap this video up, we've created streams for the raw data, the cleaned data, and the prediction. We've also created 3 projects to ingest and clean the data, and also produce the prediction. The fictional bank in our scenario can now plug the prediction into their transaction processing system to either approve or deny the transaction.